Hey, ladies and gentlemen, Mr. Brescher here. Today's goal is that we're all going to be able to accurately subtract with rational numbers, which would include integers, positive and negative fractions, and decimals. We have some sample problems here, -3/4 minus -1/2, or you could even say -75/100 minus -5/10. Let's look at a number line to help explore some connections between addition and subtraction. First of all, we have 4 minus 3, a first grade level problem, and I think we all know that the answer is 1. You would start at 4 and take away 3 or move backwards 3 units to get the answer of 1. Well, if we compare this to a very similar integer problem, we could say this is the same as 4 plus -3 because we start at 4, and when we add -3, that tells us to go back 3 units, and we get the same answer, 1. So really, what we're doing is you're starting at the first number with an addition problem. You're going to move left for a negative and right for a positive. But we have to be able to make the connection between the subtraction problem and the addition problem. And that the big key is to use what we call keep change opposite, or add the opposite. Notice the first number does not change. It stays the same. So our starting position on the number line is always that first value. The second number, though, becomes its opposite, and we're adding. So we keep the first number the same, and then we add the opposite of the second number. And that's how you can change any subtraction problem into an addition problem. And then we know how to model the addition of integers using the number line. Let's look at some other examples. So we have 2 minus -5. We would want to change this to an addition problem, so I'm going to keep change opposite. Opposite of -5 is +5. And now I can model it. Start at 2, and I'm going to add 5, so move to the right 5 units, and I end up at my answer 7. Let's try another one. Here we go. Keep the first number the same, change this minus to a plus, and this becomes the opposite. So the opposite of 5 is -5. And now we could say start at -3 and move to the left 5 units. So we go 1, 2, 3, 4, 5, and I get my answer, -8. And one more. Again, use this keep change opposite. Change it to an addition problem, and then we can think about how we model that addition problem on the number line. So keep the first number, change the minus to a plus, and -6 becomes its opposite, which is +6. The first number tells me where to start. Start at -2. And now I'm going to move to the right. Since it's a +6, I'm going to move to the right 6 units. 1, 2, 3, 4, 5, 6. I end up at my answer, 4. So if we use keep change opposite, then we're back to adding. And we should all be able to add integers by this point, or at least think about how you would add them or model them on a number line. Let's move on to some practice problems with fractions and mixed numbers. So again, we're subtracting with positive and negative fractions and mixed numbers. Well, the first thing we want to do is change it into an addition problem. So we're going to do keep change opposite. Once we've changed it into an addition problem, now we're going to follow the same steps. Convert to a common denominator if necessary, combine or add the numerators, and simplify. So in this case, we're going to convert to a common denominator, and that common denominator is 4. We have to create this equivalent fraction. Notice 1/2 is equal to 2/4, and that should actually be a positive 2/4. Okay? And then we're ready to combine them. So we're going to combine the numerators, and we have -3/4. So the numerator, in a sense, is -3. Whoops. And the other numerator is 2. So we're combining them. Negative 3 plus 2. I would start at negative 3 and move to the right 2 units. That's all I'm thinking about, that model on the number line, which would leave me at negative 1. And my answer here is a negative 1/4. And there we have it, negative 1/4. Over here with mixed numbers, again, first convert it to an addition problem. So we keep the first value the same, change the minus to a plus, and this becomes the opposite of 1 1/2. So we have negative 1 1/2. Our next step is going to be to convert to a common denominator. In this case, our common denominator is 10. So we convert both of these into equivalent fractions. 1/5 becomes 2/10, and 1/2 becomes 5/10. Now we're ready to combine the numbers. Remember, when you're adding two negatives, it's kind of like adding two positive numbers. It's just that you're going to start at the negative and you're going to move farther to the left on the number line. So your answer is definitely going to be a negative. In this case, we're going to combine the whole numbers and combine the fractions. The reason that we have a negative 2 and a negative 5 here is because when we have the number negative 3 and 2/10, we got to remember this whole value is negative, not just the whole number, but the whole number and the fraction. Same over here. The negative 1 and 5/10, not just negative 1 is the negative, but both parts of this, the whole number and the fraction, are negative. And that's why the negative 2 and the negative 5 appear here. When we combine these, the whole numbers, we get negative 4. And for the fraction portion, we end up with negative 7/10. And finally, we combine both of those to create our mixed number, which is negative 4 and 7/10. Moving on. Now we're going to do some practice with decimals. And when we're subtracting with positive and negative decimals, again, we want to do the same thing. We're going to use keep, change opposite, or add the opposite. So in this case, my first sample problem, I'm going to keep the first number the same, and I'm going to change the minus to a plus. Negative 5/10 becomes its opposite, which is positive 5/10. Now I have to think about how this is modeled on the number line. I'm going to start at this number and I'm going to move to the right. I'm still going to be in the negatives, but it's going to be getting closer to 0. So this is like subtracting with positive numbers. In this case, I'm going to take 2 7/75 minus 5/10. But I have to realize that since I'm starting farther to the left than the amount that I'm moving to the right, my answer will be a negative. You can annex the 0 and subtract as if they were whole numbers, and then bring the decimal down whenever you're done. We get an answer of negative 2 25/100. For the next problem, again, we're going to keep the first number the same, change the minus to a plus, and now the 5/10 becomes its opposite, negative 5/10. Now, if we think about how we model this, we would start at the negative 4 36/100. And then we're going to move farther to the left on the number line. So in a sense, it's like adding two positive values because you're getting farther away from the 0. It's just we have to realize our sum is going to be a negative value. So line up the decimals and add just like their positive values. Annex the 0 if it makes you feel a little bit better. And when we add those together, we get our answer, but we have to realize again, it is a negative value because when we add two negatives to get together, you're going to start to the left of 0 and move farther to the left, which ensures that your answer or sum must be a negative. And drop that decimal down. Let's do some practice. Here we go. Don't forget to use keep, change opposite, and then think about how you would add those values. So keep, change, opposite. What'd you get? Great job. How about the next one? Keep the first value the same, Change the minus to a plus. And then the opposite of negative 5, 6 is positive 5, 6. Did you remember to convert to a common denominator? Remember, you're starting at negative 2/3, which is the same as negative 4, 6. And you're going to move to the right 5, 6. So it's like start at negative 4 and move to the right 5. We end up with our answer 1, 6. Let's try the next one. Negative 4, keep, change, opposite. What do you get? That's right, you should have gotten 1. Moving on to the next one. Keep, change, opposite. And what did you come up with? Great job. Here's another one. Keep, change, whoops, there we go. Opposite. And what did we come up with? Great. You realize that when you have one number negative and one number positive, so if they're opposite in signs and you're adding them, that it's kind of like subtracting with whole numbers, because 12 and 1500ths minus 4 and 2/10 equals 7 and 9500ths. But since the negative 12 is farther away, your starting position is farther to the left of 0 than the amount that you move to the right, we have to realize that our sum is going to be a negative value. Let's try the next one. Keep, change, opposite. And again, we have a similar situation, except for this time, our negative value, negative 1 and 2/3, we're actually going to move farther to the right than the starting location of this. So we are going to get into a positive value. We could also say our positive number has the greater absolute value. Therefore, the sum will be a positive value. But in a sense, you're subtracting these two numbers. You should have gotten 3, 6. Whoops. Which is equal to 1/2 when we simplify. There we go. On the next one, again, keep, change, opposite. Convert to a common denominator, which would be 20ths. And then combine your numerators and simplify. When we simplify or convert this back into a mixed number, we get negative 1 and 3/20ths. And our last one, I just gave it away, but when you do keep, change, opposite, you have two negative values, which is just like adding two positive values, but we have to realize our sum would be a negative 10 and 133 thousandths. So I hope that helped you out with understanding subtraction of rational numbers. See ya.